for your computer science problem, including your placements, including your gate preparation, including your semester batches, including the machine learning also. So on this particular channel, you are getting every solution. So before we go further, let me introduce myself. My name is Vishvadeep. I have written the GATE exam multiple times. This is the rank. Apart from that, I have the rank 119 and 440 also. Plus I have rank 682 in my third year itself. I went for my masters to IIC Bangalore. Another masters I have done from BITS Pilani in the data science. The rich experience of teaching I am having, and these are the courses I am dealing with on Unacademy's platform. If you are aware about the Unacademy's platform, well and good. If not, then check it out, just because there also you will be getting lots of free content and even in more interactive manner. So go to Unacademy's platform and go for special classes. Okay, so first of all, you need to search my name so that you can reach to my profile, and after that you can follow my profile over there. In the profile, you will be getting special classes. These special classes are special just because these are free. We conduct so many special classes live. Today also I am going to have a new live session at 4 p.m. about some more question solving. So you just go to Unacademy's platform, follow my profile so that you can get all the notifications of my live classes. Plus, there are so many classes which I have taken already. Those you can listen in the recorded mode, and these particular classes you can watch in the recorded mode and you can learn a lot. If you want all my previously taken special classes in a playlist kind of mode or in organized way, then you need to go to this particular URL. Go to this URL. Over there I have managed all my special classes in more organized way. To unlock these free special classes on Unacademy's platform, you will need a code, and this particular code is this VDeep10. This code you will need to unlock all the special classes, all the free content. Use the code, remember the code, use the code, unlock free content from the Unacademy's platform. And then if you guys are waiting for any kind of test series or willing to go for any kind of test series, this is the free test series we guys are having for you guys, which is absolutely free. Enroll for that and go for the quality questions and their practice. If you are waiting for, or if you are willing to go for your best kind of preparation, whether it's 21 or it's 22 or any kind of gate year, then we have one particular platform for you where you can get solution of each and every of your problem. If you are facing the problem of quality education, we provide there. If you are facing the problem in solving the questions, then that we will improve there. If you are facing the problem of writing the test or doubts or any kind of thing, wasting a lot of time, and you want to utilize maximum of your time with the maximum productivity, we provide all these solutions on Unacademy's Plus. So once you go for Unacademy Plus, you will be getting live classes, weekly tests, doubt solving, and so many other things that you will have your preparation going to the perfect direction. This particular Unacademy Plus subscription you can take with multiple different packages. Then the packages are 24 months, 18 months, 12 months, 6 months, 3 months, and 1 month. And all these packages you can get including a minimum 10% discount if you use the code VDeep10. So you use the code VDeep10 to unlock the free classes. You use the code VDeep10 to unlock the discount. You use this particular VDeep10 code so that you can connect your preparation with my team. Who is my team? What is my team? My team is a particular bunch of 7 members who are going to give you every single subject's preparation for your gate, will help you in your preparation, will give you guidance in your preparation. This is the team which will help you in your entire preparation duration. So if you want to have a connection between my team and your preparation, use the code VDEEP10 and take the subscription as soon as possible. If you are the person who is not good in the planning, you don't want any kind of planning to be done by yourself, then we provide you an expert in a specific kind of special kind of subscription which is called as iconic subscription. This subscription has all the facility of Unacademy plus extra facility of a personal coach. This personal coach will be expert who will be preparing the strategies for you. He'll be preparing the planning for you for your day-to-day activities, will give you study booster sessions. You'll be getting personalized test analysis so you can rectify the problem whatever you were facing in the test, in the quizzes, and hence you can improve day by day for the next test. And definitely you will be getting some extra practice sets and notes also in this particular iconic subscription. This iconic subscription also comes with the discount if you use the code VDEEP10. This particular code is not only for discount, this particular code is to make the deep connection between your preparation and my team's effort. So if you are going to take any kind of subscription, if you are going to go for any kind of unlock on the Unacademy's platform, remember this code VDEEP10. This particular code you will use and you will get lots of benefits. Okay, so all the informations from my end is going to come for your BST and previous year gate questions next. But before that, you need to be ready. You need to be ready for what? You need to be ready for your understanding, for your learning, for your explanation. So if you are ready, type down in the comment box you are ready, and you are going to have the good explanation, the actual explanation of each and every topic next onwards. But for that you need to be ready. Type down in the comment box aap ready hain, and then we will start the session. Now if you are really serious about your preparation, concentrate on study, concentrate on learning, and then let's see how we are going to solve these questions which are upcoming questions in this particular session. A binary search tree, it's a gate question of 1996. A binary search tree is generated by inserting in the order following integers. The number of nodes in the left subtree and right subtree of the root respectively is. First of all, we need to generate a BST by inserting these keys. And after that, we need to calculate how many keys will come into the left subtree of root and how many keys will come into the right subtree of root. First of all, let's draw the tree. So basic idea of solving this particular question. Basic idea of solving this particular question is draw the tree, which is the regular approach. Draw the tree. Karte hain. 50 is the root. Then next 15. 15 should be in the left of 50. You know the definition of BST. Smaller values in the right side, greater values, smaller value left side, greater values right side. 62 greater than 50, it should be in the right side of 50. Then 5 should be in the left of 50, left of 15. Then 20, smaller than 50 but greater than 15. Then next is 58, greater but smaller than 62. Next is 91, 91 is greater than 62 also. 3 lesser here. Then 8 lesser greater than 5. 37 lesser greater and greater than 20. Then 60 greater than this but less than 62 greater than 58. At the end 24 should be in the left of 37. Now how many number of nodes are there in the left subtree of the root? 1, 2, 3, 4, 5, 6, 7. 7. 7 number of nodes are there in the left subtree, and in the right subtree, how many number of nodes in the right subtree are? 4. Now, this is the regular approach which we have solved using the regular method, that draw the tree and get the answer. if you are going to be the topper, you don't waste a single minute, not even the 15 seconds also in the GATE exam. So you need to find out such kind of methods through which you can solve each question in the less time. So if the regular approach suppose is taking 1 minute, you should solve, or you should be able to solve a question in just 30 seconds with some kind of trick, some kind of tips, some kind of special knowledge. And here it is, that particular knowledge I'm going to give you. If such kind of question is asked, look at this. What is the question? How many number of nodes should be there in the left subtree and right subtree of root? First of all, whenever you insert the element in the binary search tree, the first element becomes root. And now you know all the lesser values of 50 should come into the left, greater values should come into the right. How many values in this sequence are lesser than 15? 1, 2, lesser than 50. 1, 2, 3, 4, 5, 6 and 7. These 7 values are lesser than 50, means should be coming into the left subtree of root. And right subtree of root is having what? Right subtree of root should have greater values than 50. Greater values than 50 means, greater values than 15 means this one. 1, 2, 3 and 4. So directly sequence you just check out for such kind of question. Just observe that how many values are lesser than 50 should be coming into the left subtree. How many values are greater than 50 should be coming into the right subtree. Answer is done. My answer will be very simple. 7, 4. B option is correct. You don't have to draw the tree for that. You don't have to draw the tree for that. I hope you guys are understanding this. I hope you guys are understanding this. Okay, fine. Another question. So remember this learning, that every time you solve the question, you need to find out some kind of unique way to solve the question with the required knowledge, so that you can solve the question in less time and hence you can save the time in GATE exam, which is very necessary for you guys. Next one. Next is, a binary search tree is used to locate a number 43. Which of the following probe sequences are possible and which are not? So probe sequences is nothing but which particular sequence is a valid sequence to search 43 in a binary search tree. If you are watching this particular lecture for the first time and if you don't know how to do this, on the same channel you go and check out a data structure playlist created by me only and taught by me only. In that, the very first lecture of binary search tree is having this particular explanation, that how exactly you are going to locate or you are going to search an element in a BST, and you need to just check out that the given sequence is valid or not. You can easily understand that particular lecture, and based on that we are going to solve this particular question. So first of all, the value is 61. So 61 should be on the root. We are comparing 61 with 43. Not equal? No. 43 should be in the left of 61. Yes. So we should go towards left. Next value should be lesser than 61. Yes. From 50 to 43 is lesser. We should go towards left. Okay. Next value is lesser. No problem. From 43 is greater. We should go towards right. Next value should be greater than 14. Yes. 17, from 17 43 is greater. Yes. So we should go towards right. 40, and we should go towards right from 40 to search 43. Fine. Is this particular sequence was correct? Yes, direction wise correct. We were going into the correct direction, and next value also managed based on left right, small greater. Just check out that this particular tree is a binary search tree or not. Every value is in the left of 61. Yes, so you can see every value should be lesser than 61. Yes, it is there. Now 52, every value is in the left of 52, lesser than 52. Yes. Now every value is greater than 14, should be in the right side, greater than 14. Yes. Every value is in the right side of 17, greater. Yes. Every value is in the right side of 40, here downside, greater than 40. Yes. So option A looks correct. This is a correct probe. Now let's talk about option B. Let's talk about option B. For option B, 2. From 2, 43 is greater, we should go towards right. 3, greater value, fine. From 3 also 43 is greater, we should go towards right. Next value should be greater than 3, 50. From 50, 43 is lesser, we should go towards left. From 40, 43 is greater, we should go towards right. And from 60, 43 is lesser, we should go towards left. So left right direction is fine. Let's check it out that this particular tree is a BST or not. क्या ये ट्री BST है या नहीं, चेक करो. So 2, every value is in the right of 2, should be greater, fine, no problem till now. 3, for 3 every value is in the right side, should be greater than 3, yes, fine. For 50 every value is in the left of 50, should be lesser than 50, here is a wrong value. 60 is wrongly placed in the left subtree of 50, which is wrong. Left side of 50 में 60 नहीं आ सकता, not at all possible in a binary search tree. That's why this particular B sequence is wrong. Okay, let me use black color for this one. Now C option. C option says what? Let's check out C option 2. C option value is 10. Next value greater 65. 65 से 43 should be in the left. So next value should be lesser 31. From 31 43 should be in the right. Next value greater 48. 48 से next value should be in the left. Why? 43 is lesser 37. 37 से 43 should be in the right. Check out if this particular tree is a BST or not. 10, all the values in the right, greater, fine. 65, all the values in the left, smaller values, fine. 31, all the values in the right, greater, yes. From 48, all the values are in the left, smaller, fine. 37 say right side value, greater value, yes. So C option also looks correct. Now let's go for option D. Option D. What I am going to now check is, we are going to use a short trick now. We are not going to draw the tree. We will start from here only. 81. To search 43, from 81 you should go towards left. If you are going towards left, every value which you will encounter from here onwards should be lesser than 81. Should be lesser than 81. Sab chota hai 81 se. Every value is lesser than 81. Yes. Let's go to the next one. 61. From 61, 43 should be in the left. Every value after 61 should be lesser than 61. Lesser than 61. Let's go. Lesser than 61. This one. Every value, yes. From 52. Now next step is 52. 43 is lesser than 52. Every value should be less than 52. Yes. Yes. Let's go for a 14. 14, 43 is greater than 14. You should go towards right. Every value after 14 should be greater than 14. Yes. Next step is 41. From 41, every value should be greater. Why? Just because 43 is in the right of 41. Yes, there. No problem at all. This is a correct sequence. Valid sequence. Let's go for option E. Option E, 17. 17, 43 is in the right of 17. Which means we should have all the values greater than 17. Yes, no problem. Next, 77. 77, from 77, 43 is in the left side. If it is in the left side, we should go towards left side, and every value after 77 should be lesser than 77. It is there? Yes. 27. 27, from 27, 43 should be in the right side. If it is in the right side, then from 27, every value should be greater than 27. No, it's not. It's not. Means this particular option is also not a correct sequence. So A, C, D are the correct sequences. B and E are not the correct sequences. I hope you guys understood how to draw the tree, kind of this path tree, to get it, yes or no, or even directly also without drawing the tree also you can get the same answer. So you need to just check out that how exactly you are going to solve, and based on that you can easily get the answer. Another question. Insert the following keys one by one into a binary search tree in the order specified. Show the final binary search tree after insertion. Let's do that. First of all, 15 to be on root. 32, start from root, check out 32 should be greater than 15, so it should be in the right of 15. Next is 20. 20 is greater than 15. Here 32 lesser than 32, 20. Next is 9. 9 is less than 15, should be inserted here. Then 3, 15 ka left and left. Then 25, greater than this, less than this, greater than this. 12, lesser than this but greater than 9. Then 1, less than 15, less than 9, less than 3 also here. Here it is the final binary search tree. Now what they say, draw the binary search tree after deletion 15 from here. If you delete any node from the binary search tree, we have 3 different cases. Case 1, if the node is having 0 child. Case 2, if the node is having 1 child. Case 3, if the node is having 2 children. When the node is having 2 children, then either we can replace the node to be deleted by its in order predecessor or successor. I will give you both here. If suppose this was the option or point A, question number B, if suppose we are deleting the node with 2 children. Look at this. We need to delete node 15 which is having 2 children. So if we are deleting node with in order successor, with in order successor, what is the in order successor? In order traversal after 15, which node should come? After 15, in order successor is 20. So first of all, remove 20 from here. Remove 20 from here. So if you will remove 20 from here, 25 will be in the left of 32. And after that, you need to replace 15 by 20. You need to replace 15 by in order successor 20. So 20 will come here. Remaining nodes will be as it is. This will be the tree after deletion. After deletion of the node 15 with the in order successor. Suppose if you are deleting the node using deleting node with predecessor, node with in order predecessor. In order predecessor means just before 15, which node should come? 12 in the in order traversal. आप करके देख लीजिए in order traversal just before 15, 12 should come. Deleting node with in order predecessor. So if I will replace 15 by in order predecessor, in that particular case, 12 should come here on the place of 15. So 12 should come here, right side as it is. And in the left side, 12 will be removed from its place. 9, 3 and 1. This should be the tree. Now, in this question, as they have not mentioned exactly that using what you need to delete in order successor or predecessor, just because it was a subjective question, we have given both the answers. We have given both the answers. You could have gone with any of the option in that particular subjective type answer, and if there will be an objective question, then definitely they will mention in the question that using what you are going to delete the node with 2 children. Very welcome everybody, whoever have joined us little late. If you haven't liked the session, please session को like कर दीजिए. And then now we are going to solve another question of almost same type. Okay, let's see what it is there. Suppose the numbers these are inserted in that order in an empty binary search tree. Okay, the binary search tree uses the usual ordering on natural numbers. Yes, we know that. What is the in order traversal of the sequence resultant tree? Now the question is very simple, that in order traversal of a BST is what? The regular people will do what? Will draw the tree, and based on that they will give the answer. First, regular people will do what? They will draw the tree and they will give the answer. You are not the regular people. You are the intelligent enough, smart enough to remember such kind of small concepts. The in-order traversal of a binary search tree is always a sorted sequence of the keys. Sorted sequence of keys. In which order? Ascending or descending? Ascending or descending? Ascending order. In ascending order. So in this particular case, just assign or just align these numbers in ascending order and you will get in order traversal, which is option C. Without solving the question, you can get the option. Just read. It will take hardly 10 to 15 seconds. After that, tick mark, 2 seconds and done. You don't have to draw the tree at all. You don't have to draw the tree at all. So it's very simple thing. When you understand the concepts, it's always easy to solve the questions, tough questions also in the less time. चलिए आगे बढ़ते हैं. Another question we have. Another question is what? A data structure is required for storing a set of integers. Fine. Set of integers we are storing in a data structure such that each of the following operation can be done in order of log n time, where n is the number of elements in the set. Okay, so n is the number of elements and we need to have a data structure in which the following operations can be done in the log n time. First is deletion of the smallest element. Fine. Second is insertion of an element if it is not already present in the set. So if the element is not present, then insert. Which of the following can give you the answer in the log n time? Let's see what happens. A heap can be used but not a balanced binary search tree. First of all, you need to understand a binary search tree is what and a balanced binary search tree is what. Binary search tree, you already know. Left side smaller keys, right side greater keys. But what is a balanced binary search tree? Balanced binary search tree is that's by BST in which the left subtree and right subtree's height will be almost equal. Almost equal means the difference between the height of left and right subtrees can be maximum 1. Maximum 1. So balanced binary search tree will always have its height in terms of login around the login. So in the balanced binary search tree also you can insert and delete and you can search the element in login time. If the search tree is balanced, then the operation of insertion, deletion and searching can be done in login time. So heap can be used to delete the smallest element. Yes, possible. Heap can be used. Why? Just because if you manage a min heap, then find out minimum value which is on the root, delete it and adjust the tree so that it takes login time. So deletion of smallest element done in heap in login time. Yes. In the balanced binary search tree, yes. So in both you can do both of the operations in login time. Both balanced binary search tree and heap can be used. Yes, C option is correct. C option is correct. Balanced binary search tree can be used. Yes. Heap can be used. Yes. If you will have a min heap, you can definitely get a value. Okay, चलिए आगे बढ़ते हैं. अगला क्वेश्चन ये रहा आपके सामने. नेक्स्ट क्वेश्चन वेरी सिंपल अगेन. The following numbers are inserted in an empty binary search tree in this order. What is the height of BST? The height is maximum difference or maximum distance of a leaf from the root. So what is the height? Let's first check out how to draw the tree. You know that 10 root. Next value 1, insert here. 1 is lesser than 10, left side. 3 less than 10, greater than 1. Then 5 less than 10, greater than 1, greater than 3. Then 15 greater than 10 in the right side. Then 12 greater and lesser. Then next 16 should be greater than 10, greater than 15, 16 should be here. What is the height of this tree? Distance maximum distance from root to the leaf. From here, maximum distant or farthest leaf node is this 0. From here to here 0, 1, 2 and 3. Answer is height of the tree is 3. B option is correct. B option is correct. I hope you guys understood this. Okay, चलिए आगे बढ़ते अगला क्वेश्चन ये रहा. The numbers 1 2 3 4 5 6 7 up to n are inserted in a binary search tree in some order. So you are inserting 1 to n numbers in some order, not necessarily in the same, but in some order. In the resulting tree, the right subtree of root contains p number of nodes. Right subtree of root contains p number of nodes. The first number to be inserted in the tree must be whichever element you insert at first in a BST, that should be root. That should be root. So ultimately what they are asking is, tell me what is the root element. चलिए, first of all I'll explain you using an example. एक example ले लेते हैं. Let's see n is equal to 7. Means you are inserting an elements 1 2 3 4 5 up to 7. Fine. After that I have taken an example. I have taken p value is equal to suppose 2. Means whatever the sequence you have inserted, you have root. In the root's right subtree you have two values, p values, which are 2. In the left subtree you will be having remaining values. So what are the two values you will be having in the right subtree? If you have n equals to 7, definitely you will be having 6 and 7 here. Definitely you will be having 6 and 7 here. And definitely in the left subtree you will be having 1, 2, 3, 4, so that you can justify the definition of BST, and the root will be having value p, value 5. Root will be having value 5. Now based on and p, can you get the value 5, the root value? Yes, which is nothing but n minus p. Got it? Now the same thing I will explain you. N minus p. C is the correct answer. If you have right side two values, then p will be, or n minus p will be the root value. You can check out the example check करो. n की value 7, p की value 2, root पे होगा 5, right side two values 6 and 7, left side 1 2 3 4. Now the same thing I will explain using the mathematics. Look at this. They are asking the root, right? If suppose in the right side you have total p values. Total suppose n values are there. If total n values are there, can you tell me how many number of values should be there in the left subtree? How many number of values should be there on the left subtree? Number of values should be there in the left subtree is equal to n में से p minus करो -1. Why -1? ये root को हटाना पड़ेगा. Remove the root 2. So if p values are in the right side, n minus p minus 1 values in the left side, total you can get how n minus p minus 1 plus p values plus 1 root equals to n values. Got it? Understood that? Now listen. If p values are in the right side, left side n minus p minus 1 values, left side of root should contain all the lesser values. If all the lesser values you are containing in the left side of the root, you should have 1, 2, 3, 4, 5 up to n minus p minus 1 values. If I am saying you have inserted in a BST 1 to n numbers and BST is there, in the left subtree of root you will be having all smaller keys. So all first n minus p minus 1 value should be in the left side of the root. So if you are having these values, first these values 1, 2, 3, 4 up to n minus p minus 1 values here on the left subtree, root पे क्या होगा? Plus 1 value, and in the right side all the values after that. एग्जाम्पल देखो, यहां पे है अप टू 4 वैल्यूज, लेफ्ट साइड में अगर है 1 2 3 4 तो रूट पे है 4 प्लस 1 5 वैल्यूज. सो आई कैन से दैट द वैल्यू एट रूट इज इक्वल टू n माइनस p माइनस 1 प्लस 1 प्लस 1 वैल्यू विच इज n माइनस p वैल्यू. Mathematically also I have proved here. Yes, Anvesha, exactly correct. Exactly. So mathematically, example के through, anyway, both way, you could understand how we have solved this question. So if examples are easy for you, go for it. If not, then go for such kind of mathematics, whichever easy for you, but do it quickly in the GATE exam. Here I am taking time so that I can explain each and every small thing about that. You don't have to explain somebody in the GATE exam, right? You will have to just solve and get the answer. Another question. Correct. In this previous question, the numbers were sequential. That's why only this particular question was having such kind of answer. Suppose that we have numbers between 1 to 100 in a BST and want to search the number 55. Which of the following sequences cannot be the sequence of nodes examined? The same question we have already solved. That what sequence is correct to search some element and what is not. 55 if we are searching, let's check out option A, 10. From 10, 55 should be greater. Means we are going towards right. If we are going towards right, every value after 10 should be greater than 10. It is. Now 75. From 75, 55 is lesser, towards left, every value should be lesser than 75. Yes. 64. From 64, 55 is in the left side. So every value which you will encounter should be in the left. So should be lesser. Should be lesser means all the values are lesser than 64. Yes. 43 say 55 is in the right side. Every value should be greater than 43. Yes. 60. From 60, 55 is lesser. Towards left, every value is lesser. Yes. From 57, 55 is lesser. Towards left, yes, 55. No problem. Option A seems fine. So they are asking about cannot, means option A is fine. It can be a correct one. It can be a correct one. So let's go for option B. Option B, 90. From 90, 55 is in the left. All the values should be lesser. Yes. 12 say 55 is greater, should be in the right side, means every value should be greater than 12. Yes, it is. 68, 55 should be lesser than 68. Every value should be lesser than 68. Yes. 34, every value should be greater than 34 in the next. Yes. 62, lesser values. Yes. 45, greater value. Yes. Option B also seems correct. Option C, let's see option C. 9. 55 is greater, go towards right. Every value greater, no problem. 85. From 85, every value should be lesser. Yes, why? Just because 55 is in the left side of 85. Yes. 47. From 47, 55 is greater. Every value should be greater than 47, but not. 43 is not greater than 47, but it is in the right side. It is wrong. But we will check for option D also. हम D के लिए भी check करेंगे. 79, 55 is lesser, go towards left, every value is lesser. 14, from 14, 55 is greater, go towards right, every value should be greater than 14. Yes. Next, 72, from 72, every value should be lesser. Yes, every value is lesser. From 56, 55 is lesser, go towards left, every value should be lesser than 56. Yes. 16 से 55 is greater, go towards right. Every value should be greater than 16. Yes. 53 greater 55. Yes. So only option C cannot be a valid sequence. Great. Such kind of two questions we have solved already. Okay, fine. Another question, same type of question. अब ये वाला question जल्दी solve करेंगे, जल्दी, quickly. Same type of question, multiple times they have asked in the gate. Same type of question. To this particular 37 to 573 you are having, you need to search 273 unsuccessfully. Doesn't matter successfully or unsuccessfully. We are searching element. Yes, we need to check out that which is correct one or which one is not. So encountered correctly. So which is the valid sequence? That is the question. Let's talk about this. 273 greater, every value should be greater than 81. Looking fine. 537, 273 is lesser, every value should be lesser than 537. Yep, fine. 102, 273 is greater, every value should be greater than 102. Fine. 439 is 273 is lesser than 439. So every value should be in the left of 439. Every value is lesser. Yes. 283, 85. 285 से 273 is less. So you should go towards left. Every value should be lesser than 285. नहीं है, gone. Second one, 57. Every value should be greater. Yes. 97, every value should be greater. Fine. 121, every value should be greater. Fine. 195, every value should be greater. Fine. 242, every value should be greater. Fine. 381, every value should be lesser. Why? Just because from 381 to 73 should be in the left, but they have gone into the wrong direction. Second one is wrong. Gone. Third one, 142, 273 is greater, right side. 248, 273 is greater, right side. 520, every value from here is greater than this. Yes. 248 से greater है. Yes. 520, 273 is lesser, every value should be less than 520. Yes. 386 lesser, every value should be lesser. Yes. 345, every value should be lesser. Yes. 270, every value should be greater. Yes. 307, fine. This seems fine. Option third seems fine. Let's go for option fourth. 550, every value should be lesser than 550. Yes, fine. 149, every value should be greater than 149. Fine. 507, every value should be lesser than 507. Fine. 395 say 273 should be in the left. Every value should be lesser than 395, but not means wrong. Only third is correct. Such kind of 3 questions today only we have solved. These are the all gate questions. So such kind of questions can be asked in the gate exam. You should have a good practice of solving these questions quickly so that you will not waste the time. Another question, which is true. The cost of searching in an AVL tree is big of log n, but that of binary search tree is this. Yes, correct. Big of n. Yes, correct. Why? Just because binary search tree can be a skewed tree. Can be a skewed tree, possible hai. Cost of searching AVL tree this, but that of a complete binary tree is this. Is this a true? The cost of searching an AVL tree is this, but that of a complete binary tree is n log n. Is this true? No. In complete binary tree also you can have searching using a linear kind of search or a traversal. You can search in log n, in n time only. You can search in n time only. Just visit each and every node. Compare if node is present or the element is present. Fine. Not, then not fine. So complete binary tree or any binary tree, if you are searching, though the regular tree binary trees are not used for searching, but still if you want to search, you can have a traversal with n time and your searching will be done. N max. Yes. The cost of searching in a binary search tree is this, but AVL tree is this. No, not at all possible. AVL tree में log n time ही लगता है. It's a balanced BST. Cost of searching in AVL tree n log n, not at all possible. Option A is correct. Option A is correct. Next one. While inserting elements these in empty BST, in the sequence shown the element in the lowest level. Now listen, lowest level is not level 0 root. Lowest level means the maximum level number. Lowest level means root is the on the highest level, and कौन सा नोड है जो बहुत दूर है नोड से, बहुत दूर है रूट से, that is the lowest level node. Look at this. Let's see. 71 is root. 65 if you are inserting in the left of 71. Then 84 greater than 71. Then 69 left and greater than this. Then 67 less, greater, less. 83 here. So which value is on the lowest level? Lowest level value is 67. B. Good, nice, amazing. Next one, another question. Let T be a binary search tree with 15 nodes. Find the minimum and maximum possible height of T are. The height of a tree with single node is 0. If single node is 0, let's have a tree with minimum height first. Minimum height. 15 nodes minimum height. How can you arrange 15 nodes minimum height? Arrange maximum nodes on each level so that height will be minimum. Look at this. This is minimum height. H is equal to 3. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, 15 number of nodes are there. 15 nodes are there. Height is 3. How? Array, single node height 0, 1, 2 and 3. Height is 3 with 15 nodes. So height is 3. Either B option correct or this D option correct. Maximum can be what? This is the minimum one. Minimum height is 3. Maximum is what? Maximum will be like this. Skewed tree. Every level single node. Every level single node. In that case, this is level number 0. This is level number 1. For 15 nodes, maximum height can be what? Maximum height can be 14 or 15. 40. Maximum height can be 14. So 3, 14 will be the correct answer for this question. Again, very simple question. Very, very simple question. Okay, next. Oh, next is done. We are done with all BST questions. Now what I am doing is I am going to have 2 days break in this particular GATE data structure PYQ. Okay, so for next 2 days we will be solving the PYQ at 12 p.m. of COA for next 2 days. Why I am doing this? Just because my data structure course is going parallelly. And in that data structure, I would like first to complete the BST in its explanation, and after that I will come here and I will solve the remaining PYQs of BST. So for next 2 days, we will be solving PYQs of COA and more specifically on memory organization. So whatever the memory organization questions we are having, those questions I will bring, and for next 2 days we will be solving at 12 p.m. And of course 7 p.m. I am already going with my BST explanation. So today we will be having in the BST insertion and deletion, and based on that we will be having the complexity analysis in the BST. Once this will be done, then tomorrow in the same 7 p.m. BST binary search tree discussion on YouTube, we will be having the BST concept through questions. So I will bring some different types of questions for you, and based on that we will learn how we can solve those questions on BST. Those questions are, every question is unique, and how to solve those questions you will understand, you will learn in that particular thing. Plus these are the YouTube sessions. All these are YouTube sessions. Plus today I am going to have a 4 p.m. session on Unacademy's special class. This particular special class is at 4 p.m. and in that particular class I will be discussing COA previous year questions of 2005. Why this 2005? Just because yesterday we have solved some PYQs of 2013 and which were asked in last time IIT Bombay paper. This time we are going to solve 2005 PYQs of COA of computer science, and those today 4 p.m. special class on Unacademy for free we are going to have. So these are the 2, 3, 4 sessions which I am going to have in the next sessions. All of these are free of cost. You can attend live. In fact, you should attend these classes live. All the members who want to unlock the Unacademy Plus subscription or Iconic subscription, or on Unacademy you want to learn for free also, you need to use this particular code VDEEP10 for unlocking all the learning possibilities from my team. This is the team of which I was talking about. This particular team is having members who have cracked at least one competitive exam with the great rank, with a good rank. So all these members have either cracked GATE or some kind of another exam or PSU or something. कुछ ना कुछ किसी ने क्रैक किया हुआ है, कुछ ना कुछ किसी ने अचीव किया हुआ है. So all these are achievers and having great experience of teaching. So all of you should attend each and every class which is going to happen here live, so that you can have the maximum learning out of your given time. Okay, so we have Satish Yadav sir for discrete math and DBMS. We have theory of computation, CD and C language taught by Malesham sir. I am taking COA and data structure. We have Arun Kumar sir who is taking machine learning and data science topics. Operating system taken by Khalil sir. Discrete math taken by Satish Yadav sir again, and then Pankaj sir is taking computer network. One more teacher is going to be added in this particular team in just 2 days. Yes, in just 2 days we are going to launch a new teacher on this particular channel. He will be coming and he will be teaching you live courses for your GATE preparation. So be live every time and come to this particular session. Every session, whichever the session is going to happen here, every session you need to attend live. And then if you want the PDF of all these lectures, you can go to this particular Unacademy GATE CS channel of Telegram, and then over there we will drop all the PDF, plus we will drop all the announcements and everything of the new classes or whichever the classes will be there. And if you want to be connected with us on Facebook, this is the Facebook channel which we are having for you guys to be connected with us. And one more thing you need to do is, if you have friends, colleagues, your juniors, seniors, any family member in other domain also of engineering, and they are preparing for anything, if they are in the engineering, if they are preparing for GATE, ESE or any other exam which is related to engineering, then you should recommend these channels to them. For electrical ECIN, we should have, or you should recommend this particular channel, Creatrix GATE channel. For mechanical people, this one. For civil people, this one. SSC, JE, GS Terminal, we have a channel of quality education. You just recommend them the channel. We have Unacademy Computer Science channel. It's your own channel. You need, every time you need to share the lectures and their links and playlist and the channel link to all of your friends, so that they can get the opportunity to learn for free with the quality education which you are providing here. Every time you come here, you should like the videos and please share the lectures. If you haven't subscribed the channel, subscribe kar lo channel ko and turn on the notifications, so that every time I come for the class, you will be getting the notification. Thank you so much for your dedication and dedicating your time for learning here. Keep your learning happily keep learning. Thank you so much. We will see you soon. Till then, have a nice day.